Today I'm presenting on mainframes and the mainframe operating system ZOS. So first, who am I? I'm a fifth year BSMS CSEC student. I've worked at IBM on X-Force Red for 2 summers, and I'm going back to that after graduation. And I really only talk about mainframes. Here's some pictures of me with mainframes and a little Lego one that I got at work this summer. So, what is a mainframe? I didn't know that this was a real thing until last summer. I thought this was just a fancy word for server or some other type of computer, but it turns out that mainframes are a distinct thing and they're very cool. So, historically, a mainframe was the frame that held the main CPU for an organization, and this was back in a time when it wasn't standard for every company to have a bunch of computers. There wasn't even personal computers. They usually just had one, so then they would have the mainframe. Today's are very powerful computers that are focused on high reliability and processing a lot of transactions at once. So redundancy is a really important feature of mainframes, and they're designed for industries that can't have a lot of downtime. And going off of that, who uses mainframes? A lot of companies have them, but they're especially popular in industries that require bulk data processing, such as credit card companies that are having probably millions of transactions a day, reservation systems such as booking flights or hotels, and insurance companies. Over 90% of the top banks have mainframes. And mainframes process 68% of the world's production workloads, which I thought was really interesting because most companies probably don't have too many of them. They're just really good at doing a lot of transactions really quickly. So since these are very historically interesting computers, I want to cover a little bit about where they came from and how they got to be the mainframes that we have today. So this started out with the IBM 701 in 1952. And this was IBM's competitor to the UNIVAC, which was the first commercially available computer. For this time, it had very quick ability to perform calculations and had a big storage size for that time. And you could only rent these, you couldn't buy them at the time, and there were 19 units available total. And we can see the price to rent it was $16,000 a month, which in 1992 is a lot of money. 1952, I said 92. And then the next big iteration of mainframes was the 1401 data processing system, which came out pretty soon after the last one in 1959. This is the one that led a lot of companies to switch from using a punch card system to getting an actual computer, although it did still allow you to work with punch cards if you wanted to. Another interesting feature of this mainframe was that it actually came with some software included. Before this, you just got the computer and your company had to have developers that were able to build a program for that. So if you were using it for banking needs or whatever, you had to start from scratch. And this came with some basic things that companies could at least use to get started. By this point, the price had also decreased significantly, and it was $25,000 a month. So a lot more were sold. And then finally, we have the System 360, which is the first time when there was multiple varieties of this same family of computers released for companies that may have different processing needs. Before this, every mainframe that you got had a different operating system, and you needed to develop new software. So if you upgraded, you had to redo all of your programs. And now it made software a little bit more portable and allowed companies to start actually developing applications that they could use for a long time. Then we have modern mainframes. Starting in 2000, we have the Z900, which is the first mainframe to use the current Z architecture. This moved from a 32-bit to a 64-bit system, but it is still backwards compatible back to the 1964 version of the mainframe. So if you had a program that ran on that, it will still run on the Z architecture mainframes. And the Z stands for zero downtime. They're expected to get less than 5 minutes of downtime per year. Most recently was the Z16. It comes in the 1 to 4 frames. So the picture here on this slide is a single frame unit, and if you get the 4 frame one, it's 4 times bigger than that. The processor has an AI accelerator, which can run deep learning operations really quickly. One use case for this is credit card companies that want to run fraud detection on every transaction that happens as it happens. So if we look inside the mainframe, what is actually in there? This is a 2-frame system. So it's a little bit bigger than the one on the last slide. Since reliability is really important with mainframes, they have backup power supplies that make sure it will stay up no matter what, even if the normal power source is lost. There's a lot of input and output things on a mainframe because you typically connect them to other devices. Even storage is not included as part of this. That comes in a separate rack that you keep with it. That was actually in one of the pictures I had on the first slide. Had a mainframe and the storage system. And then the screen and keyboard you see there is the support element. This is used for actual operation of the mainframe. There's a lot of processors, and each processor drawer can contain 4 chips, and each one can have up to 12 terabytes of memory. And then, of course, cooling is important because it's a big computer that makes a lot of heat. One of the big things about mainframes is that everything is divided into logical partitions, which is basically like a VM. So a mainframe comes with a type 1 hypervisor called Prism, and you can build on current systems up to 85 LPARs, which can have a variety of different operating systems. This allows you to really customize what you need. So if you have one partition that needs a lot of memory, a lot of I/O, and maybe a lot of devices connected, you can do that. And if you have another one that has less intense needs, you can make a smaller scale one. This allows a lot of flexibility and keeps separate workloads. So there's a lot of different types of processors that a mainframe can have. The central processor is used for normal work, just like any standard computer processor. There's the integrated facility for Linux, which is just for running the Linux operating system on a mainframe. This is because from a licensing perspective, it's more cost effective to use this processor than to run it on the central processor. It also removes some instructions that ZOS, which is designed for mainframes, use, but Linux doesn't need. Then there's the integrated coupling facility, which is for parallel sysplex. I'll talk about that later, but it's basically another way to provide redundancy. There's the integrated information processor for Z. This was originally for processing database workloads, but now it's used a lot for container management. The system assist processors help move data between storage and the processors and I/O, which makes it faster because the central processor doesn't have to focus on that specific task. And then there's the integrated firmware processor, which is for system management and operations. Any of these processors can take jobs from any of the LPARs that are on your system, and so it's just kind of based on priority. So if you're setting up a mainframe, you have two options for how to do that. First, there's the support element, which was shown in the picture. That's the screen and keyboard that are physically on the device. There's usually two, one that's for primary use and a backup just in case something happens to it. But a lot of the time, your administrator doesn't want to be in person on the mainframe, so there's another option called the hardware management console for remote management. This does all the same things as the support element, but it allows you to actually manage multiple mainframes from the same spot. So one HMC can manage up to 100 mainframes, and one mainframe can be connected to 32 different HMCs. You have a question? You know, I'm actually not sure. I haven't used that. When I've interacted with mainframes, I'll get into this a little bit, but I've primarily used TSO, which is a way for users to interact with it, or SSH. So since each of your LPARs can have a different function, it would make sense that you'll want a variety of different operating systems to meet these needs. ZOS is what IBM designed to run on the mainframes. This is really good if you need the most use out of your hardware. It's very efficient, and it was designed specifically for this. If you really like Linux, you can use any variety of Linux. There's ZVM, which is a type 1 hypervisor that can run any of these operating systems, including another ZVM. Then there's ZTPF, which is the transaction processing facility. This is an operating system specifically if you need to be processing a lot of transactions, such as your credit cards or your airline reservations. This was actually created as the airline control protocol, and then they expanded it to other uses as they realized that there's multiple use cases for having high volumes of transactions. And then ZVSE is for smaller mainframes if they don't need as much power. And the reason you'd go with this is because I think it's a little bit cheaper for licensing. None of these can run directly on the mainframe. You have to run it through the hypervisor that comes on there, Prism. So what is ZOS? It started out in 2000 and was the successor to the previous operating system, OS 390, built specifically for Z architecture. This licenses for about $125 a month, which actually doesn't seem that bad if you're a business. And you'd choose this if you're running COBOL applications, if you need that backwards compatibility all the way back to 1964, you're trying to maximize your hardware performance, then you would want ZOS. But if you're not that specific about it, you can use Linux. In 2000, mainframe started supporting Linux, and IBM developed a special distro called ThinkBlue just for running on the mainframe. But today, you can use anything you want. Red Hat, SUSE, and Ubuntu are officially supported. This does make it a little bit interesting because ZOS and mainframes have their own encoding using EBCDIC instead of ASCII. You can't interact with it through the 3270 display terminals, which is the traditional way of connecting to a mainframe. And so you need to do a lot of converting between different types. And Also, if you have files on Linux, you can't access them directly from other operating systems because it just won't be compatible. They've also developed a special mainframe hardware just for Linux, and that's the Linux one here, that's the orange one. So how do you actually use the mainframe as a normal user? Because not everyone is just going to be setting up these operating systems. There's going to be applications running on it. Like say you're a banker and you want to be able to process these transactions. How do you do that? So the traditional option is TSO, and this operates over a special protocol called the 3270 protocol. Originally, you'd use this little terminal that's up on the screen. It was a physical console that you would go to, and that was connected to the mainframe. But today there's 3270 emulators, and this allows you to connect to the mainframe remotely and issue commands. This can be a little bit complicated. The command format isn't like what we're familiar with from Linux, and sometimes if you get an error or something, it's really difficult to figure out what you did wrong, and it's really difficult to go back and fix it because it just kind of gets stuck in a loop of, oh, you have an error, and you don't know what to do, and then you kind of panic. This happened to me a lot this summer. But then, thankfully, most modern mainframes do support SSH, which works just like SSH on any other computer. You can use Linux-style commands. Things are scriptable. You can do authentication through either a password or keys. And this is handled through a feature of ZOS called Unix System Services, which allows it to run programs written for Linux without having to set up a specific VM just for that purpose. So what happens once you log in? You log in with TSO, and then typically this will bring you to a program called ISPF. This is a panel application that operates through menus, and the picture shows it there. So this is your start screen when you first log into a mainframe. And from there, you have a lot of different options. You can look at data sets, which are kind of like files. You can run commands. There's a text editor. Basically, anything you can do on a normal computer, you can do from here. It just looks a little bit confusing when you're starting out. Then there's an application called OMVS, which gives you a Linux-like terminal and also has a more traditional file structure that we'd be familiar with, because the way data sets are organized isn't hierarchical like files. They're just there. I haven't quite figured that out yet. That's actually something I've been trying to learn more about, and I've been working with data sets a lot, but it's a lot to get used to. So you would type in what option you want. Usually I would go for option 6 because that brings you to the terminal. So I talked about how we can increase reliability through something called parallel sysplex, and this picture shows what it is pretty well. It's if you have multiple mainframes and one of them fails, you want to be able to transition those workloads over to the other ones basically instantaneously. So you'll have the coupling facility, which is one of the specific processors on the mainframe that handles everything about switching over to the other ones and keeping them all up to date. They all have to be time synchronized, and through their I/O management, all 4 of the mainframes in this diagram can connect to the same data sources so that they have instant access to anything they need should something fail. The most common is parallel sysplex, where you have multiple mainframes like this and they all can work together. But you can also have a monoplex, which is just one for testing, or you can have a base sysplex where instead of being managed by a coupling facility, they all just connect to each other directly. ZOS has a lot of components that are different from a normal computer. So here's a couple of them. There's the resource management facility. This is important for monitoring your performance and making sure that everything is where it should be. The system modification program, SMPE, is really important because when you can't have downtime, doing an update can be really concerning. You don't want anything to break, you don't want your software to stop working, you don't want it to take too long. So the SMPE helps do these updates in a safe way that won't disrupt your current system. There's DFS-MS, which is the disk management program. This makes sure that there's backups, can perform data migrations or do copies, and it manages I/O between where the data is actually stored and the mainframe. The workload manager just helps prioritize transactions and sharing the resources. I talked a little bit in the SSH section about Unix system services, which allows you to run your Unix programs. And then there's the end user interfaces like TSO or ISPF. And then since these have some of the most important data that a company deals with, security is very important on the mainframe. So this is handled through something called the security server, which has all of the components that handle security for the system. This is like all your firewalls, LDAP, Kerberos, and then they have RACF, which manages all the permissions. There's actually several products that can do this role, but RACF is the one that IBM designed, so that's generally what they would recommend. And RACF is the Resource Access Control Facility. It has profiles for each user and each resource on the mainframe, and it's in charge of everything from identification and authentication to access control and authorization and logging. So when you want to, say you want to log into an application, it will make a request to RACF and say this is who the user is, are they authorized to access this? And RACF will provide an answer. It doesn't block them. It's up if they're not authorized, that's up to the application. So basically it returns a yes or no, are you allowed to do this? And the application that requested that has to handle it properly. Yeah.
So is like RACF like only built to run on the IBM like security mainframe?
Yeah.
Okay. Like it can't be like deployed on like something else.
Right. It's just for the mainframes.
Between like in functionality between that and like something like
I think it's what I think of it as most similar to is something like PAM on Linux that just has all of the information about who can log in and authorization and stuff like that, and then programs have like a centralized place that they can ask. So yeah, it would be kind of similar to Active Directory too. So then since mainframes are for processing a lot of data, I'm just going to talk briefly about how you do this because I find it to be a little bit confusing. It's been something I'm also in the process of learning about. So jobs are programs that you'll run multiple times with different inputs and outputs. So things like a credit card transaction needs to be processed immediately, but payroll only needs to be processed at the end of the week. So then this would be counted as a batch job, which will run whenever there's extra resources available on the system. These are run automatically without user interaction and just done whenever there's resources available. The job entry subsystem is a component of ZOS that's in charge of managing jobs, such as the queuing, the priority, and scheduling. So in this, all of these jobs are written in JCL, job control language, and I have an example of it up here. It's a little bit confusing, but basically you say, this is the program I want to run. So this can be any program you have on the system. It could be something written in COBOL. And then you can define inputs and outputs to that program. So say you want to take information from some data set and, as a very simple example, multiply all the lines in that data set by a certain number. So you'll define this is the input data set, this is the program to run that will do that multiplication, and here's where I want the output to be. And you define all of that in your JCL, and then you'll run it. It'll get sent to the job entry subsystem for prioritization. The thing that actually got me interested in mainframes in the first place was COBOL. This is a business language that a lot of mainframe applications are written in, and since not a lot of people know COBOL anymore, you can make a lot of money as a COBOL developer. So I thought that sounds pretty cool. I'm going to learn about it. Turns out it's not very fun to actually work with, but if you are into that, you can make a lot of money, because even though this language was developed back in 1959 when mainframes were just starting out, 43% of banking systems are still running with COBOL in 2017. I think this was also a pretty big problem during COVID. Like, a lot of old government programs, they realized just couldn't be supported as well as they would like anymore because not enough people knew COBOL. And this would be, yeah, there's been a lot of changes to it to try to keep it modern. Like, go ahead. Yeah, they actually made it object-oriented at some point, which is kind of interesting. And it's very, like, human-readable syntax. So it's kind of like writing sentences. It's very interesting. And also, if you take an old COBOL program and recompile it with modern compilers, it does function better. So there are ways to make your old programs still hold up today. An interesting note that I don't have on this slide is that VS Code actually has some extensions to work directly with mainframes. So you can connect to a mainframe with your username and password that are set up there and access whatever data sets are available to you. You can write COBOL and JCL. You can submit jobs and see the results of those jobs from within a modern IDE. So I think that's pretty cool. And then that was just an overview. We could go so much more in depth on like all of these topics, but are there any questions?